See this question, match the following. In one column we are given 4 options and in the other column we have 4 options. We have to pick one of them and match with one of these. So if you observe here, we have DMA IO, cache, interrupt IO, and then condition code register. On the right hand side we have high speed RAM, disk, printer and ALU. Now two of the possibilities here, or two of the things given here is, one is DMA IO and the other one is interrupt IO. So if you observe this, DMA is generally suitable for high speed devices and interrupt IO will be okay, will perform to some extent, will be efficient only for low speed devices. So it is better if this device is very low speed, go with interrupt. High speed, go with DMA. Now in the right hand side there are two IO devices given, one is disk and the other one is printer, and the disk is high speed and printer is low speed, and so we can clearly match this DMA to a high speed device disk and IO to a low speed device printer. And cache is generally connected to high speed RAM. The other name of cache is also high speed RAM. And the other one is condition code register. So if you remember, while discussing about our small computer, we discussed about something called as program status word. Program status word is a collection of flip-flops or collection of bits, and each bit indicates some condition like 0 or sign bit or overflow bit, carry bit, so on. In general, a typical computer will have 8 to 16 such conditions, and all of them put together, all these flags put together is also called as program status word. And one other name for the same program status word is condition code register. Now why is it called a register? Because it is a collection of flip-flops, that is the reason it is called a register. Now this one will be present inside the ALU, arithmetic and logic unit, so we have to connect them like this. Okay, and the next one is, which of the following device should get higher priority? Now some IO devices are given here, only IO devices, hard disk, printer, keyboard and floppy. This question is asked in 98. During that time floppy disk was under use, but now it is currently not being used anywhere, so no one should typically ask you anything about floppy disk in the coming years. Okay, so you can remove this option and you can check the remaining. So in the remaining options, which one should be given higher priority? I told you that a high speed device should be given highest priority. The reason is a high speed device, if it is not serviced immediately, there is a chance that you might lose data, right? A low speed device, even if it is not serviced immediately, there is very less probability that you lose data. For that reason, high speed devices will be given highest priority and they will be serviced first. In case if all the devices are giving you interrupts, we first go to the high speed device, service it, and then come to the next high speed device. So among these devices, hard disk is the highest speed device, so it has to be given the highest priority. Alright, and next one is, which of the following is true? Unless enabled, a CPU will not be able to process interrupts. So what is that they are asking is, can you put your CPU in some mode in such a way that it will not process interrupts if you don't want it, and can you allow the interrupts only when you want it? For that reason, in our basic computer also we have a flag which is called IEN, interrupt enable flag, and if this particular flag is 1, then only interrupts will be processed and we will get into interrupt cycle at T0 in case if there is an interrupt. In case if this one is 0, even if there is an interrupt, we will never look at it and we will never enter into the interrupt cycle. We finish an execution of an instruction and we get into the execution of next instruction without getting into the interrupt cycle and interrupt service routines at all. So this particular flag, every computer will have such flag. Name may be different, but there will be definitely such flag, and we will have some instructions. In our basic computer we have an instruction ION and IOF to switch on the interrupts and to switch off the interrupts, right? So if you switch on the interrupts using ION, then only we are going to deal with the interrupts, otherwise we will not deal with it. Therefore, unless enabled, if we don't enable it, our CPU will not be able to process interrupts, it will simply ignore them. So it is right. And next one is loop instructions cannot be interrupted till they complete. So what about loops? A loop is a sequence of instructions which will be executed over and again. But if you look at the way our interrupt system works, every loop will contain instructions, and after executing an instruction completely, after finishing an instruction cycle, at every beginning of the fetch cycle we check for interrupts. Therefore, interrupts processing will be done by taking one instruction as a unit, not a loop as an unit. Got it? So after one instruction cycle is over, we'll again process the interrupts. Therefore, loop instructions, this is false. Loop instructions will not be taken as a unit when you come to the interrupts. A complete instruction cycle will be taken as a unit. A processor checks for interrupts before executing a new instruction. It is false. Processor will check for instruction before fetching a new instruction, not before executing it. If you look at the instruction cycle, it will have various phases. So one phase is instruction fetch. So this is the first phase, and then we do next one is instruction decode, operand fetch, and then execute, instruction execute, and then maybe write back in case if you have it, right? So before executing, so here it will not look for the instruction. After this it will look for the instruction, which means at this point, right? So before you fetch an instruction, we are going to look for the instruction interrupt. We are not going to look for the interrupt before executing. Therefore it is wrong. And the next one is about microprocessor. Only level triggered interrupts are possible on microprocessors. Actually, microprocessors are not there in our syllabus. So this option D, I think it must be there in 1998. This is 1998 question. It must be there in 1998 syllabus, but presently we don't have it. But anyway, let me just answer it. Even in microprocessors, an interrupt can be edge triggered or level triggered. Edge triggered means we will respond during these edges, right? At this point we'll make the actions happen, and this is level triggered. Edge triggered means during this either positive edge or negative edge, if we let the registers respond, then that is called as level triggered. So when are we allowing the registers to respond? Either during the edge or during the level. So our microprocessors can be configured to respond to anything, but then most of the implementations they look for edge triggered only. The reason is disturbance will be very less when you go for edge triggered, right? If you go for level triggered, the problem is even after getting the desired value in the register, since we are allowing the register to respond throughout the time, if there is any external disturbance, there is a chance that again it might get some fluctuations. If you have this only if you make them respond only during this time, since this is a very short amount of time, it will respond and immediately it will stop, and it will not respond to the external disturbances. Got it? So this is false. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. And whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.